Class, here we are. We've got section 1.9, which is review for the test. Your warm-ups here are just simply the answers from the handout of the mapping homework from last class. Just remember, ladies and gentlemen, don't forget about your key point 00. That helps you to decide your K and your H factor. Just remember on your test, you may have the opposite where you need to, where you're given a graph and you have to come up with the equation. So again, you can take a look at your key points to see if they've been stretched or compressed to help you discover the connections between the graph and the equation. Okay, so again, these are posted here to check your answers. I only did a couple here just simply because of the space. The other answers I will have in class for you to take a look at. So here's one. Take a look at your graphs. Okay, and again, when you've gotten to your final graph, which is your blue graph here, ladies and gentlemen, take a look at your restrictions and your domains. Again, the domain is such that x belongs to a set of real numbers, but your range is such that y has to be less than or equal to the maximum, which is 3. Okay, question 2 is your absolute value question. Okay, again, in this question, don't forget A is -2, K is 1/3, D is 1, and C is 6. And again, the answers are posted here. Okay. The third one that we have, ladies and gentlemen, is the square root function. And again, you're applying all those transformations. Okay. A is 1, K is -2, D is -4, and C is -5. All right, and again, I'm missing the graph for this third one, but you can see it in class. All right, let's get with the reviewing, ladies and gentlemen. We do have a test coming up next class, so please see me whenever, whatever you need for extra help. Just remember, I've given a bunch of review topics here, folks. Please print this off and make sure you're okay with all these. Okay, is it a function? How can you tell from data points? Just remember, each x has its own y. Okay, how can you tell from the graph? It has to pass the VLT, which is the vertical line test. Looking at number 2, function notation. F at 3 means what's the value of y when x is 3. Okay, here's an example here. We have f at x equals x squared minus 2x. Find f at y plus 2. So again, you're going to sub in y plus 2 to replace x. And then you simplify that through. Another example, ladies and gentlemen, if you're given that f at x equals x squared, what is the value of x when f at x equals 25? You simply take the square root of that and then put f at 5 equals 25. So that's the opposite. You're finding the independent and the dependent value is given. Taking a look, ladies and gentlemen, most of the unit is always taking a look at domain and range. So we're going to first of all start off with our parent functions. We've got our quadratic, and x belongs to a set of real numbers, and the only restriction in your base function is that y has to be greater than or equal to 0. How does that change when we take a look at transformations? The quadratic domain should still always be x belongs to a set of real numbers, but depending on your value of a, i.e. is a positive or a negative, because that'll tell you if it opens up or down, which will give you a minimum or a maximum. Okay, so if a is positive, you have what's called a minimum. That means y has to be greater than or equal to your c value. If a is negative, you have a maximum. That means y has to be less than or equal to your c. Taking a look at absolute values in the red, ladies and gentlemen, x belongs to a set of real numbers. That stays the same throughout all transformations, but what changes is the restrictions on y. Again, y has to be greater than or equal to 0 for the parent function, but again, it depends on the value of a, if it's positive or negative, if it's going to be inverted, so it's a maximum or a minimum. All right. Now taking a look at our square root. This is probably the hardest one to deal with transformations. Okay, the regular parent function, x has to be greater than or equal to 0, and range is y has to be greater than or equal to 0 as a restriction. What changes, folks, here is your x depends on if k is positive or negative, and it relates to the d value. Whereas if you're taking a look at the range, again, it's the same if your a is positive or a is negative. And the last parent function here, ladies and gentlemen, is the reciprocal function. I find it's the easiest one to take a look at your restrictions because it's always based on your asymptotes. Okay, so your asymptotes here are x cannot equal 0, y cannot equal 0, and depending on your shifting up, down, or left, right, which is your translations, x cannot equal d, and I apologize, that should be y cannot equal c. All right, please make that correction, folks. That should be a y. All right. Just remember, folks, to review your fencing examples. There may be one of those on the test. Just make sure you're probably going to be asked for area in reference to its width. So what does that mean? You need to give length in terms of the width. That means to use your perimeter formula, P equals like 2L plus 2W, and then rearrange that to solve for L, and then substitute that value in. And then once you've got your area, don't forget you're going to need to complete the square. Taking a look at the inverse function, ladies and gentlemen, there are 3 methods. And I apologize, the bell's going to go shortly. I'm at school trying to do this, so hopefully we won't have too many interruptions. But remember, if you're given points, you just switch x and y. So ordered pair xy becomes yx. Okay, from an equation, list the steps in reverse order and operation. People get the order or the operation, but they forget that it has to do both. Okay, my easiest one that I like to do is to switch x and y and then solve for y and then let y equals the inverse function. For your parent functions, ladies and gentlemen, make sure you review that summary chart we did on one of the class days, the one where you actually filled in the handout, each parent function. Make sure you know the basic graphs and the important points. Just remember, for all parent functions, a key point that exists is 1 and 1. And that will help you if you're having to do transformations to see what's happened to that point. Now, another biggest part of this unit was the transformations themselves. Let me pause it here. Okay, folks, we're back here. We're talking about transformations. Remember, we have a general function for all transformations, which is right here. I'll provide that for you on the test. You don't need to memorize it. But what you do need to know is what all these letters do in terms of a transformation or a translation. Okay, and again, this can be applied to any parent function because, ladies and gentlemen, it's got the f or the function on the right side. Okay, so just make sure that you realize that you can't graph it in either of these forms because we're not telling you which parent function to map it with. Okay, so in this case, we know a equals 1/2. Don't forget to factor out k in this case. Okay. I apologize. Okay, so looking at this example, we know that there's a transformation. I apologize. Just 1 second. Let me pause. Sorry guys, let's just go back to that again. Whenever you're given this transformation, remember it can be applied to any parent function. It doesn't specify in this case, but don't forget, ladies and gentlemen, to look at how this formula is different than the given formula. K in this case is not factored, so don't forget to factor out K. And again, you're going to be using this mapping sequence to help you deal with that A and K transformations in terms of the compressions and the stretches in both the vertical and the horizontal sense, as well as your reflection of the x-axis and y-axis. And again, I'll provide you that formula. You just have to know how to use it. Okay? So ladies and gentlemen, don't forget in this example up here to factor out K. So factoring out K will actually change your value. So when you find K equals -1, just don't forget to rewrite it in this form. So you've got x plus 1. So in this case, D equals -1. Okay? All right. And remember, when you're doing mapping, choose points that depend on the function. Most times you're going to use -1, -2, 0, 1, 2. However, parent functions like square root function or the reciprocal may not work for all values. So choose appropriate values. And again, those are on your chart that you have on your parent functions. All right, here ends the lesson, ladies and gentlemen. Please get ready for your test. There are some questions here that have been already assigned. Make sure you go over them and you're able to solve them, as well as today's work that we're going to do in class. Okay, so again, the test will be after we have one more class lesson. All right, enjoy this, and if you see me, if you need any help. All right, have a good day.